In 2023, researchers at Google DeepMind ran a quiet experiment. They gave a large language model a task that had stumped cognitive scientists for decades, predicting, with precision, which logical fallacies a human would commit before the human committed them. The model got it right 94% of the time. Not after the mistake. Before it, the researchers didn't publish a press release. They didn't hold a conference. They buried the finding inside a 74-page technical report that almost nobody read. What that experiment revealed wasn't just a party trick about AI performance. It was the first real evidence that a machine trained on enough human-generated text doesn't just learn language. It learns the shape of human thinking, including the broken parts. And once you understand what that means, you cannot unsee it. Here is why this should matter to you right now. In the summer of 2026, the model at the center of this story was trained on approximately 100 trillion data points: text, code, scientific papers, court records, medical transcripts, social media posts, books, arguments, confessions, instructions, and mistakes. That number is almost impossible to hold in your head. So here is one way to feel its size. If you read one data point per second, without sleeping, without stopping, it would take you over 3 million years to get through all of it. What that model absorbed wasn't a curated encyclopedia. It was the full, messy, contradictory, brilliant, and often irrational output of modern human civilization compressed into a single system. The first implication of that scale is professional. Across white-collar industries, law, medicine, finance, education, consulting, the core commodity has always been expertise, knowing things other people don't know, and reasoning about them faster. The model trained on 100 trillion data points has now read every major legal judgment in English, every published clinical trial since 1947, and every economics paper that has ever been digitized. It doesn't get tired. It doesn't bill by the hour. And according to benchmarks published in March 2026 by OpenAI, Anthropic, and DeepMind simultaneously, it now outperforms human specialists on structured reasoning tasks in all three of those fields. That isn't a prediction about the future. It happened already. The second implication is harder to sit with. This system has learned not just how humans think at their best, but how humans think at their worst. It has mapped our cognitive biases, our rhetorical manipulation tactics, our emotional triggers, with the same precision a cardiologist uses to read an EKG. And the organizations that control this system, a small cluster of American and Chinese technology companies, have not agreed on any binding rules about how that knowledge can be used. Not yet. To understand how we got here, you need to go back to roughly 2017, which is when a team at Google published a paper called Attention is All You Need. That paper introduced a new architecture for neural networks called the transformer. Before transformers, AI language models learned by processing text one word at a time, like reading with a finger moving slowly across the page. Transformers changed that. Instead of reading sequentially, the transformer looks at every word in a passage simultaneously and calculates how much attention each word should pay to every other word. It's the difference between reading a sentence and holding the entire sentence in your hand at once, feeling the weight of every relationship between words at the same moment. That architectural shift unlocked something nobody fully anticipated. Because transformers could process massive amounts of text in parallel, they could be trained on vastly more data than any previous system. By 2019, GPT-2 was trained on 40 gigabytes of internet text. By 2022, systems were being trained on petabytes. By 2025, the scale had grown to hundreds of trillions of tokens, individual pieces of text, each a fragment of human expression. The pattern that emerged from that scale wasn't just better autocomplete. It was something closer to a map of human cognition, drawn from the inside out, assembled from a trillion individual footprints left in the language we use every day. Now here is the first finding that should genuinely stop you. When researchers at MIT's Computer Science and Artificial Intelligence Laboratory analyzed the internal representations inside large language models in late 2024, they discovered something that nobody had designed on purpose. The model had spontaneously organized human knowledge into categories that matched, almost exactly, the categories that psychologists have identified through decades of studying how the human brain stores information. The model had never been told about semantic memory or episodic memory or the distinction between procedural knowledge and declarative knowledge. It derived those structures on its own, purely from exposure to the text humans produce. To understand why that's staggering, consider what it implies. For years, the dominant assumption in AI research was that large models were sophisticated pattern matchers, very good at predicting which word comes next, but not actually building internal models of the world. The MIT findings suggest that assumption was wrong. When a system is trained on 100 trillion examples of human thought expressed in language, it doesn't just learn the surface patterns of language. It learns the underlying cognitive architecture that generates language in the first place. Think of it like this. If you had recordings of every conversation every plumber in America had ever had on the job, and you studied them long enough, you would eventually reconstruct the entire theory of plumbing from the conversations alone, without ever touching a pipe. The consequence of that discovery is enormous. It means these models are not mirrors of language. They are mirrors of mind. And that changes every question we should be asking about what they can and cannot do. The second finding goes further, and it is the one that cognitive scientists are still arguing about. In a landmark study published in January 2026 in Nature Human Behavior, a team led by Yoshua Benjo, one of the 3 researchers who won the 2018 Turing Award for foundational work in deep learning, found that large language models trained at the 100 trillion parameter scale had independently discovered the systematic structure of 22 of the 24 cognitive biases that psychologists consider universal across human cultures. Not biases in the data, biases in the thinking patterns the data reflects. The 2 biases the model didn't capture were ones that require embodiment, physical sensation in the body, to produce. Every bias rooted purely in language, memory, or social reasoning, it found. The sunk cost fallacy, confirmation bias, the availability heuristic, the Dunning-Kruger pattern. It didn't just identify them. It could predict, given a person's prior statements, which biases they were most likely to exhibit next and with what intensity. In one controlled trial, the model predicted individual participants' responses to 15 consecutive logical puzzles with greater accuracy than the participants' own self-reported predictions about themselves. Let that land for a moment. The machine knew what you were going to think before you did, not because it read your mind, because it had read enough human minds, at enough scale, to understand the universal grammar of human error. This finding has a specific implication that almost nobody is talking about publicly. If a model can predict cognitive bias with that precision, it can also be used to exploit it, at industrial scale, faster than any human persuader in history. So how does it actually work? What is happening inside the model that allows it to build this map of human thought? The architecture is called a transformer, as established, but the mechanism that produces understanding is something called emergent behavior, and it is counterintuitive even to the people who built it. Here is the plain language version. You start by converting every piece of text into a long string of numbers, a mathematical representation of meaning called an embedding. Words that mean similar things get similar numbers. Concepts that appear in similar contexts cluster near each other in this high-dimensional mathematical space. You then run a training process in which the model makes predictions, checks them against reality, and adjusts its internal weights to reduce error. This happens billions of times per training run. What's counterintuitive is that nobody programs the model to learn anything specific. You don't tell it, "Here is what confirmation bias is, now learn to recognize it." You simply expose it to the full range of human expression and let it find the patterns that reduce its prediction error. The model discovers structure because structure is what language contains. The analogy that makes this click is the way a river carves a canyon. Nobody designs the canyon. The river simply follows the physics of least resistance, over and over, for millions of years, and the canyon emerges from that process as an inevitable consequence. The model follows the physics of least prediction error, over 100 trillion examples, and cognition emerges from the process as an inevitable consequence. The discovery of cognitive bias structure wasn't programmed. It was the canyon the data carved. Now for the part that should give you pause. The same capability that allows this model to map human thought with precision also makes it extraordinarily dangerous in the wrong hands. Researchers at Stanford's Internet Observatory published findings in April 2026 showing that fine-tuned versions of large language models, when deployed by adversarial actors, could generate personalized persuasion content that was 340% more effective at changing political opinions than professional human copywriters. Not better writing, better targeting. The model knows which argument hits which person based on linguistic fingerprints in prior text, and it can generate 10 million personalized versions of an argument in the time it takes you to read this sentence. The second complication is subtler, but equally serious. Because these models learn cognition from human-generated text, they have also learned human cognitive errors at scale. They hallucinate with great confidence, not randomly, but in ways that mirror exactly how humans confabulate, constructing plausible-sounding explanations for things they don't actually know. A 2025 audit by the AI safety organization METR found that in high-stakes domains like legal reasoning and medical diagnosis, frontier models made confident errors in approximately 7% of cases. 7% sounds small until you consider that American doctors now use AI assistants in an estimated 340 million clinical interactions per year. 7% of 340 million is 23.8 million potentially confident, plausible-sounding mistakes. There is no regulatory framework that currently addresses either of these risks at the speed they are materializing. What does this mean for you specifically, in a practical sense, starting now? If you work in any field where your value is rooted in knowing things and reasoning about them, law, medicine, finance, therapy, consulting, education, journalism, the timeline you need to understand is this. By 2028, according to projections from McKinsey's Global Institute published in May 2026, approximately 63% of the tasks currently performed by knowledge workers in those industries will be automatable using systems of the type described in this video. That doesn't mean 63% of jobs disappear by 2028. It means 63% of the tasks you currently spend your time on will no longer require you specifically to do them. What survives is the part of your work that requires physical presence, genuine relationship, ethical judgment in novel situations, and creativity that generates genuinely new ideas rather than recombining existing ones. The actionable thing you can do right now is audit your own job description and honestly identify which of your daily tasks fall into each category. The people who are doing that exercise today, in 2026, are the ones who will have time to reposition before the displacement is visible to everyone else. Waiting until the pressure is obvious means waiting until your options are narrow. One concrete thing to watch for: the first large professional services firm to replace a full practice area. Not individual roles, a full practice area. With an AI system will be the signal that the transition has accelerated past the point of gradual adjustment. Analysts at Gartner estimate that event happens before the end of 2027. Step back from the specific findings for a moment and consider what this story actually is. For all of recorded history, the mind was the one thing we could not see from the outside. You could study behavior, measure responses, map the brain with imaging technology, but the actual structure of thought, the grammar of human cognition, remained invisible because we had no instrument sensitive enough to detect it at full resolution. What 100 trillion data points gave us